Hello, everyone. Good morning, good afternoon, good evening, depending on what time zone that you are watching this from. I am Ronald Adolph, and welcome to another live stream on the vscode channel. So, I am not going to waste any time. I want to go ahead and bring up our guest so we could have a nice surprise of what we're going to be talking about. Say hello, everyone, to Aaron Wright. Hey, Aaron, how's it going?
Hi, Reynold, and thanks for having me on the show.
Yeah, no, you're very welcome. And we have our first guest that just hopped on, Crickus. Yo, back to you, Crickus, if I pronounced that right. Um, Aaron, so what are we going to be talking about? I hear we have like a new extension that you're going to be presenting, right?
Yes, sir, and thank you for giving me this opportunity to show you this brand new extension from Pulumi. Um, Pulumi is an infrastructure as code tool, and now you can use that tool right inside Visual Studio to write and debug your infrastructure code. And this morning, we're going to take a look at how that's done.
Okay. And when you're talking about our infrastructure code, are you just talking about like any standard development environment? For those of us who are still, we have like a wide audience, some that's been coding for like 10 years plus, and some that's just new. So, what do you mean by using that term versus standard development environment?
Well, as you know, it, it's important to automate the deployment of your software. Whether it's provisioning Azure storage accounts or provisioning Kubernetes clusters, you need cloud infrastructure to host your application, to run that website, to use the cloud. Pulumi is a technology that makes it possible for you to use your favorite programming language to write that infrastructure code. Whereas some folks might use, Terraform or Helm or Ansible scripts. This is a way to write it in Python and stay in that language of choice.
All right.
Yeah.
So it's a way to allow us to use Python in order to write code that's necessary to facilitate the deployment process. Is that what you mean?
Yeah, let me give you, Ronald, a little walkthrough of a demo application that I've written for this discussion.
Sure.
All right. So I have open on my screen in VS Code a Python project. And we see this is actually a really ordinary Python program. It's got, requirements, and it's going to use a couple of libraries, a couple of packages. It's the Python package, and it's going to use this Pulumi Azure native package. And what that's going to let me do is write Python code that describes the infrastructure that I need in Azure. And when I run this program, it'll actually go and provision those cloud resources. And I can run it again and again. And when I do that, it's making sure that that infrastructure still exists and is configured the way I want it to be. And Pulumi will make changes to that infrastructure when it's different than what I want.
Got it. Okay. We have our first question here from Nikitan. They ask, does it support to deploy on AWS cloud?
It sure does. What's great about Pulumi is it has this huge registry of providers. Pulumi is able to work with any Terraform and any OpenTofu provider. And we've got providers for all the major clouds and all the minor ones too. And so, yes, in a Pulumi program, in Python, you can go and provision Azure resources like storage accounts or clusters or Gen AI services. You can go to AWS, create IAM roles, EKS clusters, things like that. And you can do that in one program.
Cool. So prior to Pulumi, what was like the hurdle or pain point that some developers had to go through that now Pulumi is helping solve?
Well, Pulumi is just such a powerful way to express those infrastructure requirements, more powerful than configuration languages and tools that you've used in the past, because you can use your preferred coding styles. You can use software the way you want to write it to describe that infrastructure. It's a much more powerful and flexible system than in the past.
Cool. All right.
Yeah. Maybe I can show you a little bit more about this program. We'll talk through it a little bit, and then we'll really get into what this new extension for VS Code can do.
Okay. Sounds good.
Okay. So just to stare at this code for a little minute, we've imported those Pulumi packages, and now we're going to create a couple of resources in the cloud. We will create an Azure resource group, and we'll assign it to a variable. And then we will create an Azure storage account. And you can see here, the storage account will be associated with that resource group. And we don't know what the resource group's name is, but we can, the name is a property of the resource, and we can bind it to the input that's needed to create a storage account.
Okay.
Also, I can use configuration. So I write this program once, and then I use this same Python code in my development, in staging, in production, all through the life cycle and into these different environments. And I can have a separate configuration file for each one of these environments. So for example, for a storage account, one thing you configure is what the SKU is, which has to do with the type of storage that you want. And so we look here at the configuration file that I'm using this morning. We see here I've configured that to be the standard LRS SKU. All right, so we draw on configuration and whatnot. And then what we'll do is we can produce what we call stack outputs, which is output information that is useful for someone who might use the software that was deployed by this program. It's also possible to use these exported values as inputs in other Pulumi programs. So you can build up a whole infrastructure that's connected in this way.
Okay.
Now, getting into what we can do with VS Code. You run Pulumi many different ways. People run it on the command line. They run it in a CI script. They might run it with a Kubernetes controller. There's even a way to use Pulumi as a library and run these programmatically. But what we'll do this morning is run it right inside VS Code. And
Cool.
That's good because this is ordinary code, right? And maybe I want to debug. And now with this VS Code extension, it's possible to not only just run, but also debug Pulumi programs in your IDE. And we're going to see that in just a minute.
Cool. By the way, is Pulumi specifically designed to only work with Python, or could it be some other languages?
Thank you for asking. Pulumi supports 6 different languages. We support Python, but we also support Node.js, including TypeScript. Okay. We support C#. We support Java. We support Golang. And we also have a YAML language for declarative configurations as well.
All right. What about BASIC from the 1980s?
Oh, you wish. But I will say my first language was BASIC, and Visual Basic was one of my favorite programs when I was a kid. So that's a special thing for me.
Yeah. Shout out to SY64138. I think it's a reset. All right. I've dated myself. All right.
Before we go on, I do want to show what I just said visually. So you can see here, I have this Python folder open in my VS Code workspace, but I also have a Node.js one. So, and this is the same program. I wrote it twice just for our discussion purposes. And so if I open this index file, here we see TypeScript. So you can use your language of choice. Of course, you get all of that IntelliSense. Like, for example, what are the different properties of a storage account, things like that. All that is available to you in any of these languages. You really just pick and choose depending on your preferences.
Okay.
And it's even composable. So there's a component model in Pulumi wherein you can write different parts of your infrastructure in a way that makes sense for you. So you might write a component in Python that describes how your organization prefers to deploy a certain thing, and actually mix that into other Pulumi programs that are written in different languages.
Cool. So there are no drawbacks to that? Anything we need to be extra careful of by mixing it up like that?
Well, we've been evolving the ways that you can write these components, and we actually are making it easier than ever now with what we call programs as components, which is a way to just write Pulumi programs in this normal way and then embed them in larger programs. So we've been making it easier and easier to do this.
Nice. Nikitan asks, does it support the latest version of .NET Core, which uses a C#, like the new iterations of .NET and like other frameworks? It doesn't like cause any risk or anything like that?
I'm afraid I don't know what versions of .NET that we support at this time, but we're obviously anxious to support the latest.
Okay. Okay.
And I will say that we strive to support cloud APIs on the day that they arrive. So, for example, when Azure API, when some new feature is released, like maybe a Gen AI service, we incorporate that and make it available right away.
Cool. Is there a page that you guys have some of that latest info that we could just drop in link for our viewers to see?
Yes, absolutely. Pulumi's documentation site has got a section for each of the languages that we support, and it'll show you how to use different providers, how to write Pulumi programs in that language.
Got it. Okay, cool.
Right on, let's jump back into actually working with this new extension. Can we do that?
Yeah.
So now we have a bit of a sense of how we write this code in Python, and it expresses, the resources that I'm going to need for running my software. Let's just run this program now inside Visual Studio. To do that, we're going to use a launch configuration. And this is something I really love about Visual Studio, or VS Code, sorry. It's just so easy to get started with debugging now. So what I'm going to do is go to the Run and Debug sidebar, and I'm going to click Show All Automatic Debug Configurations. You can see here there's a Pulumi option. And so what we're seeing now is, as we discussed, I have that Python Pulumi program written here, and I also have the Node.js one. So what it's doing here is showing us that these are the different launch configurations that we could run from that.
So were those set up when you installed the extensions, or did we have to set that up separately after the installation of the extensions?
It's totally automatic. What VS Code does is it can generate launch configurations when you click this automatic debug configurations link here, and that actually has that's a totally automatic way. And you can also write launch configurations, and maybe we'll show that in a minute.
Okay.
So let's just select this Pulumi up, and we'll actually see this program run and actually provision resources. You can see here in this debug window what's happening is it's actually going and creating an Azure storage account right now.
Cool.
Yeah. What I'm going to do quickly is put a breakpoint right here, okay? And as soon as that storage account finishes being provisioned, there's going to be a Lambda that runs. And wow, here we are breakpointing inside this Lambda. I'm going to make some breakpoints in here so that I get to the point where this code runs. And I'm going to say what this code does, and then we're going to look at its variables. As I mentioned, we want to export some information out of this program so that it can be used by other systems.
Mm-hmm.
What I want to do specifically is go and get the storage account keys that were allocated for that storage account and get one of those keys out of there and make that one of the output values. All right, so
Okay.
as we run, we actually will hit this Lambda, and we can see here on the left, here's one of these variables. So here we're actually seeing, we're debugging this program, we're seeing the key that was allocated and stuff like that.
Mm-hmm.
And then let's let that thing run to completion, and we'll see that the program has produced some of these outputs and has provisioned that infrastructure.
Okay. Now, if we weren't using Pulumi, how much time would we have had to invest to like go through all this?
It's notoriously difficult to provision and maintain infrastructure with rolling your own scripts because of how you need to do it over time. So you might allocate this storage account and then make changes to this program and run it again, and the system will compute what is the difference between what you have and what you want to have and make the appropriate changes and all in the right order. Getting all of that right from scratch is very difficult, and that's why people use tools like Ansible or like Terraform or now like Pulumi.
Okay.
We were running this program and setting this breakpoint, and I got to see this primary key value. And while this is pretty satisfying, I feel like I should make a change to my program because this is actually a secret. And I'm a little uncomfortable with this idea that this storage key is kind of in clear text everywhere. So one of the nice things about Pulumi is as you're manipulating information, you can mark that information as containing a secret, and Pulumi will then encrypt that information both in the state files and will sort of mask it whenever it's displaying this information. Let's
Cool.
just quickly make a change to our program and see that in action, okay?
Sure.
So what I'm going to do here is I'm going to use a function here, secret. So now this primary key variable that we are computing here, it will now be, that raw value will now be wrapped in this sort of secret declaration.
Mm-hmm.
So let's go ahead and just run this again. Okay, so now we see our program has reconsidered, what is my requirements? What did we do last time? And by the way, it knows what we did last time because of a state file that is maintained. So state information lets us know, well, what have we done over time? So now we see the output has shifted from being clear text to being a secret.
Yeah.
Yeah,
Cool.
so that's better. We've definitely improved the security a little bit of this software. Okay, so here I am running Pulumi software in the language of my choice in VS Code. I'm doing debugging, and before we move on, maybe I should just show that launch configuration stuff.
Okay.
Yeah. So as you know, we use the automatic launch configuration support to create this launch configuration. And again, how I did that is I clicked on this Pulumi link here, and then it discovers, possible launch configurations. I actually want to take one of these now and put it into a launch configuration file. And VS Code has got this awesome, useful little button here for that. See on this button here? I'm going to click this. Boop. Now what's happened is a launch.json file has been created in my project. And we see we've taken what was just being automatically done and turned it into a real launch configuration that it'll remember over time. So we can actually check that in.
Right.
When we go back, now we actually see it's actually shown here. And that would still be there if we were to, open this project another day. One reason to do a launch configuration is you can customize some parts of the experience. For example, you can set environment variables. You can control the stack name, which has to do with which environment Pulumi, which state is being used.
Mm-hmm.
Okay,
now,
so
are there certain like best practices that we should be aware of when configuring the files like this?
I think that's a good question. When you're using the automatic launch configurations, it will use your current stack, which means to say, when you're running Pulumi commands, you choose which environment you're targeting. I created a stack or environment called Aaron, and that is my current environment. So one thing to be a little bit careful about when you are running Pulumi in your IDE is which stack is in play, because you probably wouldn't want to, run the production stack or something like that at the wrong time. And if you're concerned about that, a way to protect it is to set that stack name right inside your launch configuration, so that even if you've selected a different stack, you're still going to use the right one when you are debugging.
Nice. Okay. We have a viewer here that says, "Hey team, do you have a plan to keep supporting the Pulumi automation API?"
Absolutely. What this user is asking about is this way that you can use Pulumi as a library. We call that the automation API, and that means you can embed Pulumi programs into larger systems. Those systems can be written in a variety of languages: Golang, Node.js, etc. And so wherever we provide the automation API, and that the way that API works is it's akin to running the Pulumi command line commands directly from Go or directly from Node.js or what have you.
Okay.
It's awesome, and it's definitely a thing we love and will continue to love and support.
Is that something that we use in conjunction with this extension, or it's just a separate thing?
Under the hood, this extension itself uses the automation API actually, because when we run these launch configurations, kind of what's happening inside the extension is what's called a debug adapter is being created, and it's using the automation API to actually do these Pulumi rollouts.
Got it. Okay, cool.
So it's just part of the whole stack of functionality that is Pulumi.
Nice.
Okay. I'd like to switch gears now, if I could, Reynold, and talk to you about a different aspect of this new extension and a different aspect of Pulumi and its products.
Sure.
We've been running this program. It has been using the Azure APIs to provision a storage account, create a resource group, things like that. Well, how was this program authenticating to the Azure cloud? If, like by default, it would use my desktop's credentials. So if I had logged in with the Azure CLI, it would have used that. But that's not what's happening here. In fact, on my CLI, I'm logged out right now. In this case, I am making use of a Pulumi product called Pulumi ESC. ESC is Environments, Secrets, and Configuration. ESC is a secrets manager and orchestrator provided by the Pulumi Cloud. And in this case, I'm using ESC to centrally manage the Azure credentials that will be used by my team and its programs to access Azure.
Okay.
We're going to get into what I just described, okay?
Mm-hmm.
Like I showed a little while ago, this Python program has got a configuration file. In fact, it's got a configuration for each stack. In this case, my stack is called the Aaron stack. Could have been called dev, staging, prod. Those are pretty typical names you might see for a stack name. This is the stack configuration file. What I have done is brought in a Pulumi ESC environment with this name. My organization has defined an environment called Azure OIDC, and my program can just link to this environment to get the credentials that this environment provides. In particular, it's providing short-term credentials to actually access the Azure APIs.
Okay.
I'm going to dig in now to how we can work with these environments in Visual Studio, in VS Code. I'm so sorry. I'm a long time user of VS Code and Visual Studio before that.
No offense taken. All
Okay,
these
good.
IDEs look the same.
Thank you. All right. So let's dig into what this means and how it works a little bit. I have in this other tab, I've opened the definition of this Azure OIDC environment, and I'm going to explain a little bit when we start to dig into this.
Wait, by the way, since you did mention like Visual Studio, do you guys have an extension for that IDE also, or is it mainly for VS Code right now?
Our focus is actually on VS Code.
Okay.
Okay. Environments are documents which can describe how to project and compose secrets and configuration. We call this secrets as code because you write these environment documents and they're like a templating language. And what we can do is author these and use them directly inside VS Code.
Okay.
Let's stare at this environment definition a little bit. How this works is you write in this values block. Of course, this is an ordinary YAML file. In this values block, we write arbitrary configuration values. For example, I've written my environment is development. These are totally arbitrary. This lets me project configurations and secrets to tools that need them, like Pulumi programs. But when the Pulumi program uses this environment, they don't use this definition directly. Instead, they get the rendered, or open, what we call the open environment, which is the output of executing this environment definition. So when this environment is actually executed, certain things happen. In particular, it's able to get dynamic information from other sources. For example, here, this block is using one of the ESC providers, and it's called Azure Login. What that's doing is using an OIDC setup that we have between our organization and Azure AD, and in that way is able to use OIDC to get short-term access tokens.
Nice. Okay.
So when this environment is actually used by a program, it will, at the moment when it's used, will use an OIDC login, get an access token, and then we can see here these expressions have bound the outputs from that process, especially the token that we get, and is bound that to environment variables.
Okay.
Any program that can work with environment variables can therefore work with Pulumi environments.
Cool.
I want to run this environment for you now to actually crystallize what everything I just said, okay?
All right. Sounds good.
For that, I'm going to use the Pulumi ESC Explorer. This is a sidebar here that shows the environments that my organization has defined. Of course, I work for Pulumi, so I have access to the Pulumi organization, and this is a dev account. And so I can see some of the environments that have been defined here. I'm specifically going to find the one that we're using here now, okay? That's this definition. I'm going to click this terminal button, and what's going to happen is I'm going to use the ESC command line to open this environment. Open means render the environment, okay?
Mm-hmm.
So I'm going to open it into a subshell. I'm just going to use my favorite shell, okay? So right now I'm in a subshell.
Okay.
If I just look at the environment variables that are in this shell, I see the environment variables that were produced by the environment, including the access token that was produced at the moment when this run command was done.
So could you tell me in what case, what scenario would this be useful to be able to do this? To see these variables?
So this ESC product is so powerful because it has all these different sources and targets that it can use for orchestrating secrets. For example, like we see here, we might want to be using OIDC to authenticate to Azure and then use that the access tokens either in a Pulumi program, like in the Python program we wrote, or in the Node.js program we wrote, or in arbitrary programs like we see here. I am just using an environment via environment variables, and any script that needs secrets or configuration values could conceivably use this.
Nice. Okay.
We also have integrations with Kubernetes and other tools. For example, this system can draw secrets out of Vault and put them into a Kubernetes secret object. There's just many combinations that are possible.
All right. We have a couple of questions here from Chania614. They ask, how do you put 3 images with the title and the heading, and then also how to do a slideshow? Like, do you make any connection with that, or is this like completely unrelated?
Sorry, I'm afraid I'm not understanding.
Yeah, China, could you explain how this relates to what we're talking about? Because I'm like, am I missing something? At least I know it's not just me. All right. So go ahead, continue.
Okay. What I'd like to do with you now is let's just go one more step into using ESC. I want to show the editing experience because that's another cool part of what the vscode extension provides. I'm going to go into my Aaron Wright account, and I'm just going to create a new environment. Okay, this is going to be called, demo. So now we see inside here I have this demo environment. Like I said, this is a definition file, and this is a way of using this expression language to get and project secrets and just configuration values whenever a program would need them. So for example, we see two example values have been created here. This is example setting, change me, example 2 setting, whatever. And we can see here, we project these values into environment variables. So let's open this configuration really quick and actually see that in action. I'm just going to do ESC run this environment, and in the subshell, just use the env command. We just see environment variables produced by that.
Okay.
So,
another question came in this time from Adam Gordon Bell, AGB. Would this replace .env files where I have my API keys?
Yes, that's a great use case for this. In fact, we even have some support for writing env files if that's the target that you would want to have for these environment variables. But yes, this is a great way to centralize secrets, not have them under Git, but also have them encrypted, and with RBAC, a lot of other features here that make it better than using an environment file.
Cool.
Yeah. So if we go ahead and do this. Oh, maybe I should do this. Does anyone know anything wrong? No, Aaron, that makes sense. Okay. One thing I want to show is how secrets are actually encrypted.
Okay.
Of course, these environment files, they can get secrets from other places. Like here, for example, we're doing that OIDC login. We can also go and get secrets from Vault, get secrets from Azure Key Vault, things like that. But we can also store secrets right inside these environment definitions. This change me kind of looks like it was a secret. I'm actually going to change it to actually be a secret. And how we do that is just like this. When I write it in this special way, this is a way to actually invoke functions in environments. So I'm going to write a secret. And when I close this and open it again, what we're going to see is that the secret has actually been encrypted. So we'll never see that plain change me text again.
Okay. Hey, just out of curiosity, unrelated, but still related, have you experimented with using AI when setting these up, like, with Copilot, or not really?
All the time. Yes. Let's even try it right now. Copilot, because we're using Python, Copilot can do a lot in helping you write Pulumi programs. It even can understand HCL and other languages and do like some conversions too. I'm just blown away by what Copilot can do.
Okay, nice. I didn't know if it was like too new, not Copilot, if like, Pulumi and like its architecture behind was too new for Copilot to give suggestions, but okay.
Well, there's a couple things definitely to say about that. If I have time, maybe we can touch on Pulumi's AI services, which make that whole experience even better. And if you want to see what Pulumi AI can do today, I definitely would point users to pulumi.com/AI. You can ask questions, have it write programs for you. It's an amazing experience.
Okay.
But for this morning, let's actually do some of that stuff right inside vscode.
Okay.
We'll take a risk right now and just try something we haven't tried yet, okay? Let's actually ask it to write more of this program for us. Like, what would it take to provision an AKS cluster?
Mm-hmm.
Okay. I'm going to use the inline Copilot just by clicking Command I on my keyboard. And now I'm actually writing provision a AKS cluster.
Exciting.
Oh, wonderful. Okay, so here we see some Python code using the managed cluster object from the container service package and actually writing out some of the specification of the cluster that I want to provision, like how many nodes, things like that. Here it's even gone and trying to generate a kube config for me.
Now, does that look all useful to you, or are there like something that you would have had to change? Like I see some red squiggly lines. I'm not sure why.
Yeah, we have to figure that out. One thing I would suggest doing is if Copilot is struggling to get the code right, in addition to the fact that you have IntelliSense here because of how our system works with schemas, and these are like rich typed SDKs, so you get all this beautiful stuff. That's one way to solve your problem. But what I would suggest doing is going to the Pulumi AI service. That's built on top of OpenAI's services, but has domain knowledge of the Pulumi SDKs and skills that help it in like writing correct programs and even programs that understand your infrastructure.
Okay.
Great. Let's just get rid of that stuff. Okay, well, maybe it's time to do a little recap now, Reynold.
Sure.
What we saw is we wrote infrastructure code in our favorite language. I wrote some code in Python. I showed how you can write that code in Node.js or TypeScript, write that code in C#, Go, Java, so many options there. Then I used Pulumi Cloud's ESC product to manage the Azure credentials that my program will need to be able to provision this infrastructure. And we did it all inside vscode. We debugged our program, we used launch configurations, and we used the ESC Explorer to be able to define and work with these environment definitions. This is all part of that larger story, Reynold, right, about how Pulumi IaC is like the most robust software engineering tools for managing cloud infrastructure. On top of that, we've got AI tooling that I touched upon that will let you do authoring and debugging and get insights into your infrastructure. And that's all that I wanted to show you today.
Cool. If you want, you could like bring up your main page for Pulumi. Okay, yes, so our folks know where to go. This is awesome. I learned a lot of new stuff I wasn't aware of before. So if people want to reach out to you directly, I know I see like the contact info right there on the screen, but if you have like some new fans, how could they reach out to you?
There's two ways to get a hold of me, but the best way, one is my LinkedIn, Aaron Wright at LinkedIn. But find us on the Pulumi Slack workspace. Pulumi Community Slack workspace is a great way to chat with our engineers and on different topics. We've got channels about Azure, about Kubernetes. So find us there. Also, as you see on the screen here, free account. Give this a try. It's totally free to get started. And at the heart of everything I've shown you is open source code. So there's a lot to dig into there.
Nice.
Check out that getting started guide as step number 2. And then finally, please give our extension a try.
Cool. All right. So we're at the point of the show where we're going to do our segment called a lightning round. Are you okay with that? It's only going to take a couple of minutes.
Absolutely.
All right. Go ahead, Peggy. Our little intro, if you got that. Can't do it without the bumper. All right. First question. If you had one extension that you need to have, you're on a desert island, what would that be? You can't use Pulumi.
One extension I have to have.
Yeah, that you can't live without.
Is it Copilot?
It's your answer. It's not a trick question.
I'm trying to think of which ones I use all the time. I mean, obviously the languages. I love the Kubernetes plugin, by the way. That I really love because some people use K9. Some people use kubectl. I do a lot of kubectl, like on the command line.
If you have to choose one, just give me one extension.
The Kubernetes plugin is like my favorite.
All right. Okay, cool. Kubernetes. Tabs or spaces? Are you team tabs or team spaces?
I'm on team whatever the repository is already using.
That sounds like a political answer.
Spaces.
Okay, I'll accept that. Light theme or dark theme?
Dark theme.
There you go. And your last question for today, we wrap up. The first guest on your own TV show, who would that be? It could be anyone alive or not alive.
Wow. First one. Does it have to be a real person?
Some organism that can speak, that could answer questions.
I don't have an answer for that.
You don't have an answer? You know what? You're like the second person that like hesitated on that. I hope it's not because of politics. There was someone that didn't want to like answer because they didn't want to like leave out people. I'm like, it could be alive or not alive. Come on, we're not closing the stream until you give like one person for a talk show host. It could be in the tech world, not in the tech world. It could be Abraham Lincoln.
I think I'd like to have Musk on the show. So
All right.
be like, what happened to you, man?
There you go. Good. Thanks so much, Aaron, for joining. This has been fun. Folks, we have the information out on the screen. If you want to reach out to him and learn about Pulumi. And that is it for today. If you aren't following us on TikTok or on YouTube, please do so and subscribe. And that is done. Thanks so much for joining, folks. I will see you in the next one.
Thanks for having me.
Thanks, Aaron.